So number 7 is an angle of elevation problem. It says a television camera is, at ground level is filming the lift off of a space shuttle. The shuttle is rising vertically according to the position equation. S is equal to 50t squared, where S is measured in feet and T is measured in seconds. The camera is 2,000 feet from the launch pad. Find the rate of change in the angle of elevation of the camera at 10 seconds. First of all, a couple things. I noticed that it's asking at time, so it would be great if I could get time worked into the formula somewhere where I start off. I'm going to draw the picture to get sort of defining my pieces here. Here is my S, my rocket is going up that way. So that's S, which was 50t squared. And I have, this is a constant 2,000. The camera is stuck over here 2,000 feet away, and my angle of elevation. So I'm looking at this picture right now. The pieces that I have is an angle and 2 segments in a right triangle. That tells me I'm going to be using trig. So I'm going to write it's opposite over adjacent is going to be tangent of theta. You could also use cotangent, but you don't want, like, you pick the one you're the most familiar with, right? Tangent of theta is equal to S over 2,000. S, because the problem's in time, it's asking you for 10 seconds. Maybe writing the formula as tangent of theta is equal to 50t squared over 2,000 would then make more sense. So that means I am going to take the derivative with respect to time on both sides. I get tangent of theta, the derivative with respect to time there, dt of, that gives me 1 over 40t squared. And it gives me secant squared theta, d theta dt, don't forget to use the chain rule, is equal to 1 over 20 t. dt over dt in this case, which is kind of convenient, is just 1. So I don't need to write that for this one here. Now we are interested in when t is equal to 10 seconds. So I'm going to draw my picture again, but for this particular example, this is 2,000. I need to find the length because I'm going to have to know what secant theta is so I can square that value. So for me to figure out what secant theta is, I need to find the lengths, all the lengths in the triangle. Now, when t is equal to 10 seconds, S is equal to 50 times 10 squared. So that's 5,000. And for me to find this last piece there, I got to use Pythagorean Theorem. So that's going to be the square root of, because there's not going to be enough room, 2,000 squared plus 5,000 squared, which is then 4 million plus 25 million, which is 29 million. And that lets me, oh, look, it's just I can take out 1,000, I think. Yeah. The square root of 4 million. Or, you know what would be easier even? I see this here, if it'll let me. Come on, buddy. I don't know why it won't erase properly. Anyways, this would be 1,000 squared, and then 2 squared plus 5 squared. That also works. Whichever way you want to think of it, it's still going to be 1,000 square roots of 29, like that. That's how that simplifies. So then, secant, well, it's the reciprocal of cosine, which cosine is adjacent over hypotenuse. So this is going to be hypotenuse, 1,000 square roots of 29 over 2,000. Okay, cool. So this is just going to be the square root of 29 over 2 is secant once you simplify all of that. Okay, so let's put all of that in. So we get the square root of 29 over 2 squared d theta dt is equal to 1 over 20 times 10. So I'm just substituting in. So we get 29 over 4 d theta dt is equal to 1/2. So our d theta dt is equal to, 2 over 29, I think. 2 over 29. And this is what we were talking about before. It's going to be radians per and then seconds in the units for that. So when we're doing angles in calculus, you are using radians because it relates to a linear measure. It relates to a length instead. All right, so therefore the angle of elevation is increasing at a rate of 2.29 radians per second when at t is equal to 10 seconds. The other option is to just use s and in the problem and then solve it that way, and then you resolve how s and t relate to one another. That also works. So let's write therefore the angle of elevation of the camera is changing, or is increasing, I would say. Increasing at a rate of 2 over 29 radians per second when t is equal to 10 seconds.